to draw the picture that is represented by the words in this question. So the length of a rectangle is 3 meters greater than twice its width. I want you to draw a picture of that rectangle and use algebra to label the sides. Okay, let's see how you did. So you need to make a rectangle. Here we go. We need to label something with algebra because we don't know it. We have to either choose the length or the width. The length is compared to the width. So if we choose x for the width, we know that the length is 3 meters greater than twice the width. So 3 meters greater than twice the width, well, 2 times x would be twice it, plus 3. That is going to be our width. So check your diagram. How did you do on that? Now, the area of the rectangle is less than 55. So now this is where we're going to take our diagram and change it into an equation. Area is length times width. So if I multiply those two together, that's my area. It needs to be less than 55 meters squared. So now we've set up an inequality. Multiplying this out, how do we solve inequalities? And this is, lately I've been trying to, we have a lesson that had 3 examples, but I did 2 the other day and left the 3rd one. I kind of like that because it's like, okay, this gives us a chance to review what we learned last class, see it again. Do we remember how we solve inequalities? Well, we solve them the same way that we solve equal equations. And then we had those test points, or we used the graph to find out which sections were true and which sections were false. So if we were solving this like an equation, we would make one side equal to 0. We do the same thing with inequalities. Move the 55 over and make one side equal to 0. And now we have to use our skills from chapter 3. How do we solve this? We could either A, factor, if possible, B, complete the square, or C, quadratic formula. And I think I mentioned last class that generally after that unit, you generally either use a quadratic formula or a factor. So you would look at this one and say to yourself, does this look like one that I could factor easily? Or is this one that I'm like, nah, I don't want to go through that mental math? I see people shaking their heads, probably a good idea. So this is typical of where you would say, I think I'll use the quadratic formula. Quadratic formula, we'll write it off to the side here. Also get rid of so this is on your formula sheet. Again, I guess for AP Math, you'd have to have that memorized. There's our quadratic formula. We just need to plug things in. So x would equal -3 plus or minus the square root of 3 squared is 9 minus 4 times a times c, all divided by 2 times a. Now, the part inside the square root, that's your discriminant. That discriminant is going to tell us if we have 0, 1, or 2 solutions. 0, 1, or 2 roots. Simplifying inside that square root, I'm going to get 9 plus a big number. $440. 440 plus 9. 449. 449 is a positive number. And of course, I should just finish this up. 449 is a positive number. That tells us that we are going to get 2 solutions to this. Okay? Is it a perfect square? Well, if I check the square root of 449, I get 21.189. No. This means that we would not have been, if we tried to factor this, we'd still be trying, because it is not possible to factor. That would have to work out to a perfect square number in order for it to be factored. What I can do with this, though, is I can plug this into my calculator. There's two answers. There's one with the plus, there's one with the minus. So I'm going to go negative 3 plus the square root of 449 divided by 4. With the plus sign, I get 4.547. And with the minus sign, I get negative 6.047. These are the places that it's equal to 0. Because we solved this just like we would solve in chapter 3. We found where it's equal to 0. If we graphed it, we found the x-intercepts. What are we trying to find? We're trying to find out when is this quadratic equation less than 0. So, there was two ways that we solved this. One was using test points. So I would put on a number line, I'd put negative 6.047, and I'd put 4.547. And remember, we did circles, and we either left them open, or we filled them in, right? And then we figured out whether it's true or false. Now, in this question, would we leave them open or fill them in? Leave them open, because if we look at the inequality, it's just a less than, not less than or equal. Okay, next, we do test points. Mental math-wise, what is probably the best point to plug in is 0. 0 would be in the middle section. If you plug 0 into your inequality, you would get 0 plus 0 minus 55. Is minus 55 less than 0? Yes. So by plugging in 0, we found out this section was true. A number bigger than 4.5. 5. If you plug in 5, you would get 5 squared here, 25 times 2, 50, plus 15, 65, minus 55 would be 10. Is 10 less than 0? No, this will be false. And similarly, if you tried negative 7 and plugged it in, it will also be false. Remember, the other way that you can check is thinking about the graph. What we found when we solved is we found the x-intercepts to be 4.5 and negative 6. The parabola that we're looking at, does it open up or does it open down? It's a parabola that opens up. So if we just did a quick sketch of the parabola, this is what we're looking for. And what are we looking for? We're looking for where this parabola is less than 0. So in other words, where is the parabola below the x-axis? Because we're looking for when are the y values negative. This is the part where the y values are negative. That makes this section true, and these sections false. So the graph really figures it out quickly, which is true and false. And I think I said last class that the graph is probably better for this unit to figure out where the true and false are. However, in calculus, you use the number line technique a lot. So it's really good to learn the test values and see that as well. Now, this is a word problem. So technically, at this point, you would want to write, we need to write our solution. And you would like to write your solution to say that x is between -6 and 4.5, because that's the true section. But because it's a word problem, we also have to think about reality and what's possible and what's not. According to this, -6 is in the true section. Can you tell me what's wrong with that in reality?
Can't have negative length in a rectangle.
Yeah, a rectangle can't have a -6 as a side length. It doesn't make sense. So we also have in this question that we can only think about positive values. You can't have a rectangle with a side length of 0. Then it's not, it's just a straight line then. So as far as our solution goes, right, make a little note. Can't have negative side lengths. I guess technically can't equal 0 either, because then it wouldn't be a rectangle. So then when we go to our solution, we would have to say that x is between 0 and 4.547. Does the question tell us to the nearest? It says to the nearest 10th. Ooh. Oh, that's not what I wanted to do. Can you see I can add the equal sign when it's the nearest 10th? Because it was 4.54. That wouldn't be included, but 4.5, because I rounded, could be. So these real world problems, there's a lot of thinking you have to do at the end. Like, oh, what was all included? My signs. Normally, this should not be an equal sign. But it is an equal sign in this one because of the situation and how we rounded. So now we've solved for x. Did it ask for anything else? What are the possible dimensions? So this would be the width, right? And then if you plug 4.5 in for x, 2 times 4.5 gives you 9, plus 3 is 12, or I guess technically we should use all of the decimal places. So I'll go back to my calculator. I'll take the 4.547, times it by 2, and add 3. I get 12.09. 12.09 for the length. I'm just going to write length here, because we don't have a variable for length. Again, the length has to be bigger than 0. Great. We'll let the computer be confused. And if I round the length to the nearest 10th, it's 12.1, but I can't put the equal sign there, because then that one I rounded up. Whew. Little complicated things in a word problem. And that's the thing about math. Actually, math is hard enough in high school, right? But the math that we do in a math class is stuff that could come up in real life, but when it comes up in real life, it is much worse numbers-wise. Like real life problems, like will always be bad decimals and bad fractions and tougher and things that don't work out. Your math class things factor nicely. Real life, it'll be like always a quadratic formula. So I think this is a good way of, there's my calculator, by the way, nicely showing up, not wanting to go away, despite clicking on everything. There we go. Okay, please circle questions 8 and 13 for practice.